So here we go. Here's what we're trying to do. We want to create a buffer of a specific pH, and that's what this is going to do, or that's what we're going to do. And I have an interesting way to find out what our pH is going to be. I have a dice here. So I want a 5, so 5.3. All right. I want my buffer to have a pH of 5.3. Okay? Now, pH of 5.3, and we'll just say we want volume, we want 0.450 liters. Okay? How do I make it? All right, now the first thing you need to do, this is acidic, so I'm going to need to do I need to find an acid. So find acid with suitable pKa value, and you really want a pKa to be close to this value, all right? Because of the Henderson-Hasselbalch equation, where pH equals pK plus the log of the concentration of. All right, this equation allows you to predict the pH of the buffer to be close to your pKa value. You have a plus or minus range of 1 greater and 1 greater in terms of pH. You don't want to be too far away, or else it's not really a buffer. If you're like on the fringe, it's going to be able to be super resilient against one acid or base, depending on what you do. All right, so these are our steps. So you find a suitable pKa, and then use this equation to figure out this ratio, and then use the ratio So that's the next step. Use this ratio, determine the ratio, and then use ratio and whatever your starting ingredients are. We're going to make, I've just kind of whipped this stuff up, but whatever you've got, like do you have 2 molar solution? Do you have a salt? Like that kind of thing. All right, I got to pause this. So now what I do is I look for my Ka values. So if you look, acetic acid, this is 10 to the 4th, so it's peak 1.8, 10 to the 5th. So this is going to be 4 something, 4 and change. Let's see if there's one. This is benzoic. That's going to be higher or lower, actually, because it's. So we want something that's a little closer, like this one, butanoic acid, 1.5, 10 to the 5th. So we've got some players here. They want us to be picked. All right, I'm going to write some of these values out. Got my 3 acids. All right. Now I want to know what's my pKa of these things. So I'm going to take the negative log of these numbers. All right, and then I'm going to figure out the pKa. First one is 4.187. 4.8. 4.7. So our targeted pH is 5.3. If you've got like a limitless supply, you don't really care about anything in terms of toxicity or anything, butanoic is the one we're going to go with. All right. So we're going to make a buffer with that, and we need 450 milliliters of it. All right. So we're using butanoic acid. So butanoic is C4H. I should look this up. 7CO2. All right. That plus water is H3O plus. All right. Now, this is important. Here's my acid. This is my conjugate. So I'm going to need to add these two things in a certain ratio to figure out my, to get the pH right. Okay? Now, I'm going to plug this into these equations, the Henderson-Hasselbalch equation, where pH is pKa plus the log of the acid-base ratio, or the base-acid ratio. So I 5.3 equals 4.8 plus log, and we're just going to, all right? So then I minus this from both sides. I get 0.5 equals log of this. And then to get rid of the log, I would take 10 raised to the 0.5 equals the ratio so I get my ratio is equal to 3.16. Okay? Now what that means is, I need another piece of paper. I need, or we need, 3.16 times more base, or the concentration of the base is 3.16 times greater than that of the concentration of my acid. All right? Now, let's just say I've got, now actually do this. Now in this part where I got my ratio and I have this piece is going to be highly dependent, the next piece is highly dependent on what you've got. Do I have 2 molar solution? Do I have 1 molar what? All right? So let's, all right, I've got 3.3 molar solution. Benzoic, butanol, sorry. Butanoic acid. All right? So, if I use this and I want 450 milliliters, all right, I need to know what, if I'm going to use this, this solution, then I plug that into my equation here, all right, and then I solve for B. So 3.16 equals what concentration of B would give me? I'd multiply these together and I'm going to get 10. I need my base to be concentration of 10.4. All right? That's pretty high, but there you go. And then this is the molar concentration. That's if I'm starting with this. This 450 milliliters didn't play into this problem because I have a molar amount. All right. If I sorry, not a molar amount. I've got I already have a concentration here. I can just plug that in directly. This is a molarity. So if I'm adding the conjugate salt, what I really need to know from this is how much salt. Well, I would take this molarity, 10.4 molar, so that's going to be moles, liters, and I'm going to multiply that by 0.450 liters. That's going to get me moles, and then I would multiply this by the molar mass of the conjugate. The conjugate salt. And then I would put that in my beaker of this stuff, of this 450 milliliters of this, and dissolve. All right? And that's how I would do it.